All right, so up next we're supposed to find the mean of a selected cup of coffee filled from this machine. And if we're supposed to find the mean of a cup of coffee, all you have to do in this case is simply add the means of the coffee, remember it's liquid, and the cup that it's going to go in. So that would just be 400. For the sake of it, I'm sure we'll see it later, but I'm going to go ahead and calculate the standard deviation of this as well. When you calculate the standard deviation of 1 cup of coffee, its square root, or in other words, whenever you find the standard deviation of a combined variable, it's going to be the square root of the standard deviation squared of item 1 plus the standard deviation squared of item 2. So this would be your formula. You'd have to round that to a certain amount of decimal places, but that's how you would end up finding the standard deviation of 1 cup. Maybe we'll see that later on. All right. Up next it says find the probability that x is less than 2. This is simply an area question, so notice that being less than 2 is essentially this triangle right here. And so what that ends up being is 2, in other words, the distance in x from 0 to 2, times the height, which is 0.2, times 1/2, because the area of a triangle is 1/2 times base times height. And so when you work that out, that's actually just going to be 0.2. All right, up next, we've got this chart right here. It says given that the mean of x, or the mean number of children, is 1.75, find the standard deviation of children such a couple would have. All right, now this equation right here, again, is on your reference sheet, and it's right here. So you can see why they gave you the mean, but up next it gets a little bit more complicated, so I'll write it out and then I'll plug it into the calculator. So the way it goes is, let's see here, big square root of each value, so in other words, 1 minus the expected value, 1.75, squared times 1's probability, which is 0.5, plus 2 minus 1.75 squared times 0.25 plus 3 minus 1.75 squared times 3's probability, which is 0.25. So now I've got to put this all into a calculator. 1 minus 1.75 plus okay, and that ends up giving me that. Round to 2 decimal places. Looks like it should be 0.83. I went a little fast. I might have made a mistake. Luckily, I did not. All right, moving right along. Actually, well, I already went away from the problem, but maybe you're sitting there wondering how did they calculate the mean as 1.75? Remember that calculation, I think we've actually done it before, but just in case, is each value times its probability. So you can kind of see that if you were calculating the standard deviation and the mean, you can see a little bit of similarity. There's still like the 1 in the 0.5, there's still the 2 in the 0.25, there's still the 3 in the 0.25, but there's a little bit more going on here because the standard deviation has to square the difference and then multiply its probability. So they're very much so related, but they can just be a little bit different, but that would be how they got the 1.75. All right, anyways, next question. In a game of luck, a turn consists of a player rolling 7 six-sided dice and counting how many of the dice show a 5. Let f be the number of dice showing a 5 in a turn. Is this binomial, geometric, or neither? This would be binomial, so let me show you how I know that. Binomial says a fixed number of trials. Now, in other words, that means we know every time we're going to roll 7 dice, right? That's the number of trials. And we're looking for how many show 5. All right, in other words, that's our x. That's what we want to calculate. And x could be 0, 1, 2, 3, 4, 5, 6, or 7, because it could be either 0 dice or all 7 dice. And then the probability for each trial, for each dice, is the same. And that's a key component of binomial probability. It's the probability from the first dice roll to the second dice roll isn't affected. And that kind of makes sense because dice are independent of one another. So each time you have 1 in 6 shot. So we have a fixed number of trials. the probability is either, essentially yes, we had a 5 or no, we did not have a 5. So that's kind of part of binomial, it's either yes or no. And the probability is consistent with each trial, or in other words, in this case, with each dice roll. Now, if it was geometric, here's what it would say. It would say, in a game of luck, a turn consists of rolling the dice until a 5 is shown. So in other words, binomial says you know exactly how many times you're going to do something and how many times did a particular event occur in those fixed amounts. And geometric says how many amounts does it take, or what's the probability that the first time a 5 shows up takes 5 dice rolls or 8 dice rolls. So that's what geometric does. Geometric essentially says how many until the first. All right. And this is the big question. If I were to, infer what's going to be in the AP exam, I would definitely anticipate a question like this. Let's see here. Actually, not quite like this. This is actually still a little bit easier. Actually, no, this is a pretty complex one. Okay, we need to find the probability that Angelita's score is higher than Cynthia's score. Now, the idea is, what that means is we want the probability that A minus C is greater than 0. Or I guess I should start by saying this. The probability that Angelita's score is greater than Cynthia's score. But the idea is if you move that C over, if you subtract it, you really are saying this. And you can kind of see that this unit has some introductory concepts that definitely show up in hypothesis testing. This kind of looks like a hypothesis testing question, and that's really not a coincidence. You're totally right if that's kind of what you're thinking. So the idea is, if you want to find this probability, well, you need to find essentially this. You need to find the odds that this is greater than 0 divided by the standard deviation. In other words, you need to calculate the z-score of this happening. And so that's actually going to look like this. So here's the key trick. If you're subtracting means, it actually doesn't matter whether you're subtracting. Your standard deviations will always add. So that's another big key concept here. So long story short, I need to figure out what the combined mean is. So what is the mean of Angelita minus Cynthia? That's 100. Minus the expected 0 is, just 0. So we have 100 divided by, and now I have to calculate that standard deviation. So square root of 96 squared plus 72 squared gives me this value, actually 120. And that gives me a z-score of 0.833 repeating. Now this is a z-score, essentially, is what we've calculated. And the idea is, if that is a z-score, what is the probability that this occurs given that z-score? And so I'm going to look at my z-table here. If I have a z-score of 0.83, 0.8 and 0.3, so that overlap is right here, that's going to happen 0.7967% of the time. So if they want me to round that to 2 decimal places, that happens 0.8% of the time. Right, so technically, I guess I shouldn't say probability equals, but the idea is that's essentially what we're calculating. And the idea is really we have to calculate, we have to write it like this. The z-score of A minus C being greater than 0. That would technically be a correct way of writing this. So the probability that the z-score, and that's what this is right here, a z-score is what you expect minus what you want, or actually it's what you have minus what you expect divided by the standard deviation. And so that was our z-score, and then we found the area of that z-score using the table. All right, up next. So people click on a particular advertisement 2% of the time. Let V be the number of times an advertisement appears to get the first person to click. Now again, right there when they say the amount of times to get the first, that automatically means geometric. Assume each click is independent. So find the probability that a person first clicks on the advertisement 8 times. And so this is actually, there's a formula on your reference sheet for it, but it's actually pretty easy because here's kind of the way to think about it. It means you're not going to click on the advertisement. So first that means 0.98, the probability of not clicking on the ad. And you're going to do that 7 times. So 0.98 times 0.98 times 0.98 7 times, or in other words, to the 7th power. finally, after you do that 7 times, you're finally going to click on the add, which happens 2% of the time. So you can see on the reference sheet here, that is our formula right there. Not doing it however many times until you finally do it. That's what geometric is. And so let me plug it into the calculator. 0.98 to the 7th times 0.02. And that's going to happen essentially if you round it 2% of the time. All right. Now this is actually a nice question. This is just a z-score question. So the question is, and you can kind of see the proper notation that I was trying to get at here in the last question, or second to last question. In this case, the idea is what is the odds that you're greater than 175? So we're just going to calculate the z-score of 175. And we'll see about that. We'll see what we're doing here. So 175 minus 150 over 20. That's 25 over 20, so that's actually 1.25. Now the idea is that's the z-score of exactly, this would be the z-score of 0, this would be the z-score of 1.25, and we want greater than this happening. So when I look at the z-table for z equals 1.25, so 1.25, 0.8944, remember that the z-table will tell you all the values less than, and that's totally indicated by the fact that the shaded region is always to the left. So what I need to do is I need to take that 0.8944 and subtract it from 1. Remember that all probability has to add to 1. So now this value is the value greater than the value that we wanted. So 2 decimal places, that would be 0.11. Ooh, 2 more. I'll just speed this video up. 60% of a certain species of tomato live after transplanting from pot to garden. Ellie transplants 16. Assume the plants live independently from each other. Let X be the number of tomato plants that live each month. Find the mean of X. Let's see here. Well, the mean would simply be the probability times how many you transplant. So 0.6 times 16. It's like 9.6. And the standard deviation is going to be a little bit trickier, and that's because of this phrase, independent. Let me see here. Okay, now the idea is, since each is independent from each other, they're technically behaving like this. We're going to have the odds of transferring tomato plant 1. Actually, sorry, I need to calculate the standard deviation. So this is actually a binomial probability. Either you do or you don't. And so binomial probability says your initial standard deviation is this right here. Oh wait, so actually I don't have to do too much. I just have to say, well, I'm doing 16 of these, and the probability of yes is 0.6, the probability of no is 0.4. So actually not as complicated as I thought at first. So we have the square root of 16 times 0.6 times 0.4. When they say independent, that's what I was kind of getting caught up on. It's the independent that makes this binomial, because again, independent means the probability won't change from one to the other. So that's going to be, when we round, it's actually going to round to 2, because it would be 1.95, and if we're rounding that to the 10th, that's going to round up. One more question. Here we go. All right, so the concept going on in this question is what we call linear transformation. So it says it cost Zainab $5 each day to pay for her own transportation, and then each customer she gets pays her $60. All right, so in other words, Y is her net gain, and what that equates to is 60 times her number of customers minus $5 each day. So that's how we're going to calculate this right here. Now this is what we call a linear transformation, and so remember, a linear transformation for the mean simply applies everything. So we're going to take the 60 times the mean of X, which is 1.8, and we're going to subtract the 5. So the mean, you do absolutely everything in algebraic order. For standard deviation transformations, you only apply multiplication. So we're only going to multiply the 60 to the X standard deviation, 1.08. And so that's a very important concept on the exam. I would definitely expect to see that. And we're done. All right, best of luck. If you have any questions, let me know on Remind.